All right, good afternoon, guys. All right, today we're going to continue our work with scientific notation. We're going to start with the warm-up. We're going to go over yesterday's homework, which was only one problem. Practice problem number 1 from lesson 14. After that, we're going to take a look at 2 tasks in lesson 15. And I have, based on lesson 15, I have another practice problem for you for homework. All right, so the warm-up for today is a little different. I know that we've been doing solving equations, but based on lesson 15, I want to make sure that we kind of refresh this, kind of like we did a recap yesterday. So you're going to simplify 4 expressions. Expression number 1, that's 10 squared times 10 to the 4th power. You should be, if you don't have your workbook with you or your notebook with you, grab those real quick so you can participate. And jot your answers down so you can check your work with us. All right, expression number 2, that's 10 to the 4th divided by 10 to the 1st power. Number 3, right, hopefully the expression you can clearly see, it's 3a minus b plus a plus 2b. And then the last one, number 4, 5x minus y plus 4 minus 4x plus y. Okay. All right, I think you guys should still be able to see that. Ignore that for now. We just have to get started with our warm-up, okay? Now, number 1 and number 2 are super easy, right? Because we did that yesterday. Hopefully, if you guys weren't with me or the class yesterday, you had a chance to watch it. It's on Google Classroom. If you didn't watch it, if you didn't see it, make sure you're checking every day, please. All right, so number 1. Number 1, 10 squared times 10 to the 4th. What do we have to do? Hopefully you tell me that since the bases are the same and we're multiplying, that all you have to do is add the exponents. So this should be 10 to the 6th power. That's right, Dagny, welcome. Excellent. I'm glad that you made it again. What's up, Kevin? Thais, great. Thank you for making it. I'm just keeping track. My handy dandy notebook, like Blue's Clues. All right, number 2. Since I'm dividing and they're the same base. Okay, remember that. Don't forget that. I do what now? It's my shortcut. If you remember. If not, it's okay. Just like yesterday, you could expand it. Oh, I'm sorry, Dagny. I thought you guys might like this. All right. Good afternoon, Camila. Dagny, if there's any kind of tips that I could give you guys to keep track. The teachers were talking that we want to try to keep it as consistent and like school as possible. So hopefully, I mean, if you just follow your regular school schedule, hopefully that would help you. It might backfire a little bit depending on what assignments are being posted and what's required. But I do know that at least Ms. Ranelli and Ms. Caruso are trying to keep things consistent for you with Google Meet. You can depend on me to be streaming during class time, each day as long as there's a school day. And the workload is pretty much the same for me, at least. I don't know about the other classes, but it's pretty much the same. So just do your best and don't stress out. And I'll try to brainstorm a little bit and think about other ways, okay, to help you keep track. I would definitely recommend maybe some type of planner or calendar that you can keep track of when things are due, especially if it's a big project that you have to spread out over a few days. I hope that helps. Back to this though, back to math. Because I think it's going to be like this for a while. Unfortunately, coronavirus is still spreading pretty quickly. So they're just trying to keep us safe, and we're going to have to all make the best out of it. 10 to the 4th divided by 10 to the 1st. Dagny, I know you know this. Thais, I know you know this. Maybe Camila or Kevin can help us out with an answer. What do we do to the... You're welcome, dear. No problem. What do you think we do, guys? And if you're stuck, I want you to expand it. This is totally doable. What I mean by expand it, Kevin, Camila, I mean 10, and anybody else who's watching, really. I don't mean to exclude anybody. It's just that they're here in the stream. So 10 times 10 times 10 times 10 is in my numerator. 10 alone is in my denominator. If you match them up, what are you left with? You're left with 10 cubed. That's right. You subtract the exponents. 4 minus 1 is 3. And that is because our bases were the same. That's why we're allowed to do that. Hey, Jacqueline. That's what's up. That's right. I hope more of you guys joined. We did a nice job yesterday. Okay, keep it coming. Keep it coming. All right. Number 3 and 4 are different on purpose, because based on yesterday when we were talking about that phrase, all right, and let's see if you can recall the phrase that I'm talking about. Right, I'm hoping that because of the way this expression looks, you guys remember the phrase I told you yesterday? What was it called? What do we do in a situation like this? We're not going to be able to solve for A. We're not going to be able to solve for B. But what can we do? We can simplify. We can definitely simplify. And what are we going to do? What do we call that? You guys remember? Combine like terms. So if the bases are similar, we're going to be able to move them around a little bit. For example, yes, combine like terms. All right. So for example, this one and this one, they have the same base. They both have the variable a. So what's 3 plus 1? It's just for a. Okay. Now, this one and this one are a lot alike. So what is -1 and +2? -1 and a +2. If you combine those two, you just get a +1. So it's plus b. And this is your answer. That's simplified. This is the expression simplified. Do you have any questions on number 3? It looks like we have more people that joined us. If you guys joined us, please type your name in the chat so that I can mark you down for attending. They are asking teachers to keep track of participation and things like this, not just your work on, your Google Classroom and stuff for submitting. Okay. Okay, last one, number 4. 5x minus y plus 4 minus 4x plus y. And again, we're combining like terms. Okay, Jorge, great. I'm glad you're here. Thank you. Harmony, what's up? Thank you, thank you. Make sure you guys have your workbooks and notebooks with you. If you don't have them with you now. Okay, so right now you know that these two, they have the same variable, so we can actually combine them. What is 5 minus 4? It's just 1, right? So for that, combining it is just x. Okay, and we're done. However, there's more that's similar. This has y and this has y. What is a negative 1 and a positive 1? Well, it looks like there's a glare there. A negative 1 and a positive 1 is just 0, right? So the y's actually end up going away. They're completely gone now. Y minus y is nothing. What does that leave me with? That leaves me with this positive 4 just kind of hanging out with no one to talk to or be around. But that's okay, because we celebrate individuality in this world, right? Plus 4. And that's it. That is the simplified version of that from your warm-up. X plus 4. All of that, and it's just meaning x plus 4. Nice, right? Okay. Any questions on combining like terms? I tried to trick you with that one. I don't know if it threw anybody off. Was anyone tempted to say 4 minus 4? I was kind of hoping you were tempted, but caught it. No one? Okay, if there's no questions on warm-up, then we're going to move on. I want to review the question from yesterday. The question from yesterday was from lesson 14. It was number 1. It had parts A, B, C, D. And if you did not have these answers, you should please let me know. What's so funny? I circled scientific notation because I was anticipating that some of you might actually have different answers, even though it's correct. Maybe you just didn't put it in scientific notation. So if you want to double check, just let me know. All right, what do you guys think? You got it? Understand it? Did we do our homework? Waiting. Okay, perfect. So no issues with the homework then, right? We can move on, I hope. I wonder, did you guys notice that for letter B and D, the answers were negative. Negative exponents, I should say. Not negative, but negative exponents is more accurate. And that is perfectly acceptable as long as they don't throw a wrench in your direction and say, make sure that there's only positive exponents. But for something like this, for scientific notation, they will probably not do that to you. Okay, so you can rest assured that you are perfectly fine. Now, Next up is 15.3. So if those of you who came late, I'll show you the agenda real quick again. All right. We just did the warm-up and we reviewed the homework. So now we're on 15.3. So everybody should be in their book, lesson 15. If you do not have your book for some reason, you know you can go online. And let's see. I don't think that there's digitals today. Nope, no digitals today. So I need everybody. Let's zoom out a little bit. 15.3 should look like this. Celestial Dance. This is one of the things that I really do enjoy about your book, your curriculum, is that they take actual scientific data, true data, something that's real, not made up. We're looking at planets and the sun in our solar system. And the reason why I circled distance is because what are they asking for in number 1? In number 1, they're looking for distances, right? So I don't want you to get confused with diameter versus difference. Distance. Distance and diameter are two different things. And that's what that is over there. Over here, I have a reminder about what diameter is. Diameter is going to be that line from one point on the circle to the other. And what's significant about the diameter is that it has to pass through a circle's center, which makes it the longest chord, if you will, or line segment in a circle. Because you can do edge to edge in a circle, or point to point, I should say, because circles don't have edges, right? You can do that, and then they're just smaller than the diameter. All right. All right. Let's take a look at what they're asking now, because we're still going to be working with scientific notation, but we're going to be doing something different today. What did they say in number 1 that's different from yesterday? For you are Dagny, you are actually thinking about circumference. Oh wait, no, no, you're not. You're correct. 2 radii, or radii. A diameter is 2 times the radius. You got it. That's correct. Now, what are they asking for in number 1 that's different from yesterday? What were we doing yesterday? Do you guys remember the salaries of all the different professions and what we were doing with them? What 2 operations were we doing with them? We were multiplying and dividing them. And in today's goal, it says that we're going to add and subtract this time. So number 1 says, when you add the distances of Mercury, Venus, Earth, and Mars from the sun, would you reach as far as Jupiter? So I circled the ones that we need to add. Hopefully you guys see that. And we're going to compare it to Jupiter. Now, what's the problem here, though? There's a slight twist here with these numbers that I've circled. And I hope you think back to your warm-up when I said we were combining like terms. Are all the bases the same? When you look at the power for the base 10, are they all the same? Okay, Harmony's asking about the warm-up. I'll show it to you really quick, but if you want to complete it and test yourself, just look back at the beginning of the stream when I post the video. You had to simplify all 4, and I gave the answers in the beginning of the video, Harmony, so you could just look back. It's okay. Okay. then we have to add and subtract. And actually, the bases are not exactly the same. Which one is different? One of them is different. All of them are to 10 to the power of 8, except one of them. Which one? Mercury, right? Mercury is the only one that is times 10 to the 7. That's right, Mercury. And that makes sense because you know that Mercury is, isn't that the smallest planet right now known? Okay. All right, so let's take a look at this. If I want to take 5.79 times 10 to the 7, and I want to make sure that it's no longer to the power of 7. Now I want to make sure that it's power of 8 because I want to be able to add it. The live keeps freezing. Just refresh it. I'm sorry. You know that we're going to definitely have 579 because the numbers are not going to change or go away. This is what's going to change. Where does this go? If I need to make it so that I'm going to have to multiply it or move it one more time, where do I put it? Do I put it over here or do I put it over here? Hopefully you guys are thinking put it right there. Because now I move that extra step. That extra step is from here to here. Now you can add them all up. I want you to add up the 0.579. I want you to add up the 1.08. Make sure, if you're on a calculator, it's not going to matter. But if you were doing this by hand, you have to make sure that they're lined up properly. Okay? Add up this with this. Ignore that for now. 1.47, 2.28. Okay, now if you add all of that up, add them all up, tell me what you get. Hopefully you guys got 5.409. And remember, it's times 10 to the 8th. Now, if this is all of them added up, let's compare it to Jupiter like it said. What's Jupiter? Jupiter is 7.79 times 10 to the 8th. Okay, and just look at your chart if you are not sure. Jupiter, its distance is 7.79 times 10 to the 8th power. So the whole question is that if you add up all their distances, would it be as far out as Jupiter? And no, right? Because this falls short. 5.409 is less than 7.79. Therefore, all of those distances added together do not reach as far as Jupiter. Jupiter is farther than all of them combined, which is pretty crazy, but it's outer space. Any questions about number 1, guys? I hope you're still with me. You guys are quiet, but like Harmony said, maybe it's freezing. Okay, cool. No? It didn't make sense? Just to recap Harmony real quick, because then I'm gonna move on to number 2. And if you still don't understand, maybe just watch the stream again so that you can follow along from the beginning. And then you can still ask me questions, and I'm here to help either way. So for number 1, I circled everything that we had to add for number 1. But the problem was that Mercury is to the power of 7. It's not to the power of 8. If you look on the list, Jupiter and all the other ones were to the power of 8, but not Mercury. So we changed Mercury to 0.579 times 10 to the 8th. That way we can take them all, we can add them all, and when we added them all, we got 5.409 times 10 to the 8th. And that's less than 7.79, so the answer to 1 is that no, if you add up all the distances for those planets, it is not as far as Jupiter. Good afternoon, Zasha. Zasha, for the homework, you didn't really have to turn it in per se. I'm just going over it with you guys. In the future, if it's less confusing for you guys, I'll just make sure that I post the problem also, even because it's in your book. So I think one of the students, Kevin, right, you took a picture and sent it to me. So if you want to do that, you can do that too, and just post it as turned in. All right, so Zasha, you've joined us. That's wonderful. Just going to jot it in attendance. Okay, let's move on to number 2. Number 2 says that this time we're going to add up all the diameters. And that's why I went over what diameter was. I reviewed it with you because I wanted you to imagine if you take all these spherical objects and if there's a certain diameter that they have, and we put them side by side by side by side, they want to know if it would actually be wider than the sun's diameter. So now we're actually in the middle column, and it said that you have to add all the diameters of all the planets. So if we do that, and I don't have to show you that part anymore. Now we're just going to add up all of those, because those are the planets. The top one is the sun. We don't want the sun's diameter here. We are trying to compare all of the planets' diameters added up to whether or not they would be the same, smaller, larger than the sun's diameter. Now, there's a big problem here, isn't there? Because what is the sun's diameter base 10? It's to the power of 6. But what are all the other ones? If you take a look in your book, all of them are a mixture of to the power of 3, 4, or even 5. So I want you guys to think about what you would actually change them to. For my purposes up here, I'm going to change them all to the power of 6, kind of like what we did here, because we're comparing it to the sun, and I think that will be easier for you in the long run. It's not the only way to do it, but it's the way I'm going to demonstrate here first, and if everybody is cool with it, then at least you have your strategy. Feel free to experiment and move on in the activity. That way you could just simply compare answers. They're different, exactly. Yep. So it becomes a bit problematic. But we got this, right? Okay, so let me put here the sun. 1.392 times 10 to the 6th. Okay, and then I'm going to put the other ones up. Hey, Sanaya, glad you can make it. We are on 15.3 in the book. That's where we're at right now, number 2. We just started it. Okay. For Mercury, Mercury is 4.878 times 10 cubed. But I want it to be to the power of 6. So how do I do that? Well, earlier you told me if I want to make that a higher exponent, I'll just move to the left more. So let's do that. Let's go from 3 to 6. We need 3 spaces. So let's go 1, 2, 3. That means that Mercury is 0.004878 times 10 to the 6th power. And if you're not sure, if you want to double check, this number would be 4,878. Let's make sure that this number would also be 4,878. 1, 2, 3, 4, 5, 6. Boom. Yeah, we did it correct. Okay. Okay, next is Venus. 1.21 times 10 to the 4th power. Makes sense that its diameter is a little bit bigger, right? Well, I should say a lot bigger. We want to make this one to the power of 6 also. From 4 to 6, we're only missing 2 spots. So we're going to go 1, 2. That is 0.0121 times 10 to the 6th. And again, if you're not sure, right here, 1, 2, 3, 4. So that's 1, 2, 1, 2. That's 12,100. And if you want to make sure here, 1, 2, 3, 4, 5, 6. Perfect. And that's Venus. We need to do the same for Earth, Mars, and Jupiter. So if you're with me and you get it, go ahead, and then compare your answers that I have up here. Earth is next. .28 times 10 to the 4th. We got to move it 2 spots. 1, 2. Mars. 6.785 times 10 cubed. It's missing 3 spots. Sasha, it's okay. Just look online to openupresources.org. And yes, you could do the work in a notebook. If you want to see the problem, go to openupresources.org. Go to Unit 7, Lesson 15, Activity 3 as a student. Okay, last one is Jupiter. This one is the closest, so we only have to move it back 1. Oh, nobody caught that. Nobody told me to, or maybe you did and it's just lagging. The whole point was that all of these would be the same so that we can compare it to the sun. if you add all of that up, okay, you're not adding that up, you're adding all of the coefficients or numerical factors. What do you get? Okay, I'll go over it again. If you guys add up these numbers right here, don't add up the sun, because that's the one that we're comparing it to. Remember, that was the whole point. We want to add up all of their diameters, and we want to compare it to the sun's diameter. We want to know, is all of them put together? Are they smaller put together? The same? Are they larger? What is it? So now that it has the same base, you can clearly see this is smaller than that. So even if you take all our planets, well, not all our planets, because it's only these ones that are listed. This one down here is Jupiter. 1, 2, 3, 4, 5. If you take these 5 planets and you line them up side by side with their diameters, they are not as wide as our sun. Why? Because 0.179363 is less than 1.392. Now, I'm going to go over it one more time, very quickly though. Hey, Gio, how are you? Okay, so in the beginning, when we started number 2, right, number 2, it said that it was only interested in the diameters this time. It says, which is wider, all of these objects side by side or the sun? All these objects meaning 1, 2, 3, 4, 5, the 5 planets' diameter. Now, I went over diameter really, really quickly. No, Dagny, this number right here. Don't do any of the times 10 to the 6th power. Leave that alone and just add up those parts. So diameter is meaning, like right there, diameter is meaning the from point to point on a circle when it passes through the center. That's a diameter. So it's basically, if you know those, during the summer, stores start putting out those big bouncy balls. They come in all these cool different colors. If you took all different sizes of them, that you could pretend that there are planets and you could put them up side by side by side, and we're talking about how wide they are, and we're comparing it to like one huge one, right? Yes, I see that. It's okay, Dagny. Try again and make sure that you only add if you add up all that I've enclosed there in that black part right here, just right over here, add that part up only, then you should get this part right here. Now, Harmony, to back up again, we needed to do all of this work because all of them needed to be to the same power, because we want to compare them to the sun. Now, you didn't have to do it this way. You could have did it another way and then compared it to the sun. That's okay too. I chose to do it that way because I thought that it might be the most simplistic. I could be wrong. Do you guys feel comfortable going from one power to the other and how it affects the number you multiply by? So for example, for Mercury, Harmony, we started, or anyone else who's a little confused, we started off with 4.878 times 10 cubed, but we wanted it to be to the power of 6. Well, if I need to go further to the right 3 places, that means I have to take the original and move it back 3 spaces. So that's why we got 0.004878 times 10 to the 6th. They represent Mercury, but they are different powers of 10. Okay. I'd like to move on to 15.4. If you guys are okay. If not, you can stop me. But 15.4 looks like this. Old MacDonald's massive farm. Not just a farm, but a massive farm. And I think they're trying to be funny. Because if you look at the very last column right here, it actually gives the mass, not weight, but the mass of whatever's listed in kilograms. Now we're used to measuring weight, and we're used to doing it in pounds. This is similar, but it's without regard to, if you remember from your science class, it's without regard to gravity. Okay, you guys are quiet, so I hope I'm not losing you. We're gonna skip number 2. We're gonna do number 1. We are going to do number 3, at least. We might run out of time after that, and if we do, you still have enough information to do homework. The homework is page 118, number 1, and I will have that posted, and for your convenience, I will post a file with it if it makes you feel better. Okay, do it in your book, but if you want it on Google Classroom, that's fine too. Okay, now let's take a look at this. It says, on a farm, there's a cow, 2 sheep, and 3 chickens, plus the farmer. They want to know what is the total mass if you combine those together. So what operation is that? They said a cow. They said sheep, chickens, and a farmer. Okay, let's take a look at the list. The question, number 1 on 15.4. Number 1 on 15.4. And the question is, what's their total mass? Yes, you do add. Thank you, Thais. I was starting to worry if you guys fell asleep or left me. We're going to add them all up, but we have to make sure that we're adding up the correct amounts, right? So let's take a look at the cow. Right now, the cow is listed. Make sure you're looking on the far right column. I almost put down the wrong number. You should be looking at 4 times 10 squared. And there's only 1 cow. Now, they're saying that there's 2 sheep. So 6 times 10 to the first power, but you have 2 of them. So you have to multiply it by 2. It says that there's 3 chickens, and the chickens is 2 times 10 to the 0 power. Remember, there's 3 of them. That's why I'm doing the times 3. But there's only 1 farmer, and the farmer, since they didn't say he's something different, we can count on the farmer being a human. He's at the top. So 6.2 times 10 10 to the first power, excuse me. I need some more coffee. Okay, so 1 farmer, 3 chickens, 2 sheep, 1 cow. Everybody with me? Now, there's a couple of different ways to do this, but you guys don't seem to like what we did in the other problem. So, I'm going to ask you to go ahead and expand that. Add it all up, like Thais said. And then when we have our answer, we're going to put it in scientific notation just so that we're still practicing that skill. Okay? Okay, cool. So 4 times 10 squared. Well, 10 squared is 100. So what's 4 times 100, guys? 6 times 10 is 60. 60 times 2 is 120. Hey, Escalin's here. That's pretty cool. What are we up to? Spread the good word, folks. Spread the good word. So at some point, at least 10 people have checked in. Perfect. Okay, cool. Thank you, Jorge. All right, nice job. Oops, wrong one. Okay, now, don't forget, anything to the 0 power is... Harmony, I really appreciate that. Please keep spreading the word because this counts. This counts as you attending school when you participate like this, all right? So if Ms. Caruso, Ms. Ranelli are meeting, any of your other teachers are meeting, you make sure that you're getting onto those meets because it counts as attendance and they will be tracking that. And for the students who are not participating or doing work, there's going to be contact home, all right? So just... yeah, keep spreading the word. Anything to the 0 power, hopefully you guys remember, is 1. Anything to the 0 power is 1. So this is like 2 times 1. And you might be saying, why? Well, a kilogram is actually really, really tiny. And chickens are tiny too. So 2 times 10, 2 times 1. 2 times 1 is 2. And then 2 times 3 is 6. 6.2 times 10 is just 62. And now I need you guys to add all of this up and tell me what you get. Yeah, 588, right? Oh my goodness. Hello, Nathan. Nathan, this is the 8th grade stream, so you're getting warmer each time. I need you on stream 9 o'clock tomorrow, okay? And if you miss it, you can get on at 10:30 because I have 2 6th grade classes. All right, buddy? Thank you for contacting me. Make sure you're checking Google Classroom, the classwork tab, so you know what's due, and you're on course to see what you have zeros on or any missing work. Perfect. Thank you. All right, 8th grade, 588 what? Kilograms. Mass, not weight, mass. The mass of all of these put together, the 2 sheep, the 3 chicken, the farmer, the cow, when you put all of their masses together, you get 588 kilograms. Now, I told you I wanted to stretch us and make us put it into scientific notation. This is acceptable for an answer. If this was a test question and they didn't tell you to put it in scientific notation, this is acceptable, but we're going to practice. How do I put that in scientific notation? Is that true or false? Oh, okay. Anything that you missed, Nathan, just look back at the video, please, because I explain the classwork, I do the warm-up, and I assign the homework. Okay, Thais says it's true, so that's good. My brain is still working just fine, and I'm not trying to trick you. 5.88 times 10 squared is the same thing as 588. Good job. All right, thank you guys. Oh, we still have a little bit more time. So what was the next question? I told you that we were going to skip number 2. So that means that I need everybody on number 3. Number 3, this time, what are we adding? We're adding a human, a blue whale, and 6 ants. Okay, I'm probably going to grade tonight because during the day I'm streaming my classes. Okay, just be patient with me. Okay, now we have 1 human, 1 blue whale, and we have 6 ants. So whatever the ant is, you have to multiply it by 6, and these are each just 1. So what is a human again? Human again is 6.2 times 10 to the 1. The blue whale is 1.9. Times 10 to the 5th power. And how about the ants? 5 times 10. Oh no, I'm looking at the wrong column again. Make sure you're looking in the mass. That I was wondering, like, that was so tiny. Like, it's got to be tiny. Ants are so tiny. How can they, really have that much mass? So yeah, this one makes a lot more sense. 3 times 10 to the negative 6 power. So what is this one right here? That's just 62, right? This one right here, what is that? Well, actually, I need more room. 1.9 times 10 to the 5th. 1, 2, 3, 4, 5. 1, 2, 3, 4. So 190,000. Wow. Wow. I guess that makes sense, right? A blue whale is humongous, especially compared to a human and an ant. So, wow. Okay. Now this one. This one, you could do the 3 times the 6, which is 18, and then 18 times 10 to the negative 6 power. Right now, our decimal is there at the end, so I just need you to move back 6 spots. 1, 2, 3, 4, 5, 6. Now, these have decimal places here. So for this one, it's actually going the other way. 1, 2, 3, 4, 1, 8. That's a tiny creature. How did you get 18? Because we're interested in 6 ants. 6 ants are in the question. So 3 times 6 is 18, and I have to do to the negative 6, and that's why it's so tiny. We are supposed to add them all up because the question says, what is their total mass all together? What is their total mass all together? $190,062 and really tiny insignificant amount right there. And we are still in kilograms. So that is their mass, not their weight. That is their mass altogether. Now, what if you put that in scientific notation? Times 10 to the what? Why are we multiplying 6 for the ants? Oh boy, oh boy, oh boy. If you look closely at number 3, they wanted 6 ants, 1 human, 1 blue whale, and 6 ants. I don't know why, but that's what they want. So that's what they get. Now, this is the magical question right here, folks. How many did I have to move it? It's perfectly okay. You ask me anything that you need to ask. It's perfectly fine. That's the whole point of this. Okay, so that was the answer, right? That 190,062 kilograms with the 0.000018, right? However, if you were going to be putting it in scientific notation, I had to move it 5 spaces. And I need it, if I multiplied it out, to be right there after the 2. So this is the answer in scientific notation. And it's still kilograms. So don't forget that. Do you guys have any questions on anything related to scientific notation or your exponent rules, which you need both in order to do well? Then the homework assignment is from lesson 15 practice problems. It's page 118, number 1, and it looks just like that. And I will post that for you. But if you guys don't have any questions on anything, maybe the Moby Max, maybe an earlier assignment, then we are done here for now until tomorrow. We are basically done with this book after we do lesson 16 tomorrow. So we're going to be studying and reviewing. It has been a while. Yes, dear. As long as you're here, that's all I care about. Good job, guys. All right, so it doesn't look like you guys have any questions, or if you do, it's lagging behind. You can post it anywhere with the video or on Google Classroom if you have a question, and I will do my best to answer you. If it's something that's going to take a while and I have to show you, then I'll probably answer it in a stream. All right? How are we going to take the test? I am still trying to come up with the best answer for that. Maybe it'll be take-home test-like, since we're kind of stuck. I'm not sure, but I will definitely let you know, and we should be reviewing for 2 days. On Classroom, yes, you do. Yes, you do. Please visit your Google Classroom. You do have an assignment that was due today. I could do a Google form. I will think about it. I think I would prefer you be able to use Kami, though. I will think about that. Thank you for the suggestion. Okay, I think we're done here, guys. Thank you for participating. It really means a lot to me. I hope it was helping you out. And I'll see you tomorrow, same time, okay? 12:30 to 1:30. Tell everybody. That way you don't miss out. All right, be safe, be good, and don't stress about the work. Just take it one day at a time, and try to use some kind of planner to keep everything organized, okay? All right, take care.